Hello. All right, I'm going to get started. So this is what I learned fixing 100 broken Kubernetes clusters. I'm going to give you all an opportunity to laugh at me for a bit, at my pain and anguish. And then I'm going to try and share some information with you about operating Kubernetes. So my name is David. I go by Raw Code across the internet. And I'm the founder of the Raw Code Academy. It started out as a YouTube channel, but now, as of September, is my full-time job, where I'm just producing content on cloud-native software. I focus on open source stuff, so if you're deploying to Kubernetes, doing cloud-native, want to get better observability, monitoring, GitOps, all those cool buzzwords, hopefully you'll find my channel quite useful. However, today we're going to focus on a show that I have called Clustered. Clustered is a show where I fix broken Kubernetes clusters. Has anyone seen it before? Okay, a few hands. The rest of you are hopefully in for a bit of a treat. I also organised and founded KubeHuddle, which is a community-driven Kubernetes conference. We started in Edinburgh last year, and we'll be doing 2 this year, one in Toronto in May, and again in Edinburgh in September. So check out kubehuddle.com if you want to learn more about Kubernetes conference. Now, clusters on paper is really simple. You'll see that green bit of text at the bottom. All you have to do is upgrade a Kubernetes deployment. And all you need to do is change the tag on the image from V1 to V2. This should take you all of about 15 seconds. However, the clusters are given to people in advance, 2 days, 48 hours typically, and they're allowed to do anything they want to that cluster to stop us from performing the upgrade. And we've learned a few things about how cruel people can be, essentially. Now, if you ever want to join me on Clustered and you like what you see here, it's really hard to find people that are willing to be vulnerable on a live stream, fixing a cluster that they had no fucking idea what's wrong. If that sounds fun to you, definitely come and talk to me, all right? Now, as I said, people are mean, and I'm going to start with a video. It's a couple of minutes long, and then there's one other really short video afterwards, but I want to give you a taste for what people do to break these clusters. On the first one, you're going to see me getting very frustrated. There are some swear words, I do apologize. And on the second video, you'll see a clip from our Teams edition, which featured Red Hat and Talos, and there's a really cool lesson in the second one. Yeah, we still have no cluster DNS. kubeDNS has endpoint. Okay, that's after A.
Yeah.
Let's see if Guy wants to jump in and give us a last bit of advice before we wrap this up. Are we close?
You've not looked at the configuration of core DNS. You've looked at the pods, but not how the pods are configured to run the DNS.
We have no DNS. Just keeps coming. All right. Did we miss something? Let's. I'm going to say cheat. I'm going to jump onto cluster 14 and grab the config map and see what's different.
What about...
Yeah, these are the exact same file. Yeah. So he told us to look in the core DNS config, and then there was nothing wrong with the core DNS config. That's just cruel. That's saying there's a few pixels. If this is a white space error in the core DNS config, I will be mighty frustrated.
It might not be a white space error. Damn.
He's mocking us now because he said your jumping back and forward showed a slight difference. This number seems arbitrary. Oh, you son of a bitch. I'm assuming there's like a weird bug, and I'm sure he's found it because he works at Skyscanner and they've got a level of scale that most people don't have. But something to do with this number going so high is maybe causing it to load an old config map in the pods or something. I don't really know. But the number being so high worries me. But we're now at the stage where I have to go and pick up my daughter. So
yeah,
I'm just going to bring Guy in to tell us what wonderful magical
what we should do.
This is, yeah. All right, Guy. Leonis.
So when you were jumping back and forth between the working config and the non-working config, if you look really hard at the C in front of it in the Kubernetes config.
Oh, you bastard.
The C?
Yeah, it's not a C. No, it's a character which looks a lot like a C.
What?
So the Kubernetes plugin became authoritative for letter that looks like a C, luster.local.
I really hate that guy. That was a long episode, nearly 2 hours we spent trying to fix this last problem. And what I love about that clip is, I promise you, I'm quite smart and I'm quite good with Kubernetes. But it had me doubting things which I know are not the fault. The fact that I think a 6-digit number is going to cause any sort of overflow on a 64-bit system, of course not. But debugging is hard. And sometimes you have to kind of remove yourself from the situation and come back to it, which we didn't do there. And we now have a new rule on clustered, which is no more Unicode breaks, ever. So, strictly prohibited, now banned, nobody's allowed to do it. And we have very few rules on clustered, but this is now one of the official ones. Okay, so failure is a success in progress. And you only learn when things go wrong. This is why I really love doing clustered. Like, if you just have a cluster that just works, you're never really going to learn how to operate that beyond a certain level of scale. And clustered brings us this situation where we can have people bring their failures from their own companies, their own organizations, their own teams, and re-replicate or replicate those issues on a live stream format that allows us to see how individuals debug it as well. Like, it's not just me that does the fixing on clustered. You know, there's always a guest or there's always a team. And you get that insight into how they approach a problem. And sometimes that's more important. You don't necessarily need to fix the cluster. You can get a lot of valuable information by just seeing how people react, handle symptoms, and work backwards. So I think that's a really strong and powerful thing about clustered and why I continue to do it. We've been doing it for 18 months and I hopefully won't be stopping anytime soon. So this talk is going to focus on this road of failures that we've kind of came to appreciate from clustered. I want to share some lessons with you, and I'm also going to talk about some other learnings that are going to come in due course.
Pretty just good.
So next is just a really short video. It's the team edition, and then I want to talk about the problem because it's also particularly cruel, but is something that has happened to that team in real life.
Pretty just go or what?
Yeah.
Let's get some notes, man.
Let's see. Permission to
Oh.
Let's check.
And you've hit your first snag. There we go.
Okay, make it +6.
Yeah. I need my autocomplete stuff. I'm lost.
You didn't install fish while you're here too?
I can type if you want.
Oh.
Okay.
Nice.
Okay.
It's an interesting start.
Yeah. Do an ls-l-a on user bin change mod, or probably just bin change mod. Oh, bother! You don't even have tab completion? What is this?
No. Yeah, it's killing me. But hey, we'll make it work.
If you don't, I think that's
Oh wait,
probably because
we can't mod that.
Yeah,
Well,
exactly. So just look at the whole/bin. Is there anything which is executable at all?
Well, ls is obviously.
Okay, so this was in the first 10 seconds of them picking up this cluster. They disabled any autocompletion on the shell. They had removed the executable bit from kube-control, and then removed the executable bit from chmod. So now they're in a position where they can no longer reapply the executable bit to kube-control or chmod, or, and if you're familiar with the Linux file system with colors, all the executable bits have been removed from the binaries in white. So they don't have change attributes, they don't have chmod, they don't have kubeadmin, kube-control, they don't have OC, I don't know why they added that terrible alias, they don't have Perl. Now, the only way I know how to fix this is with Perl, so I thought that was a particularly cruel touch. Does anyone know how to execute a binary without the executable permission? Why would you, right? But clustered gives us the opportunity to learn this. And this wouldn't have happened, this wouldn't have been a good episode if it wasn't for these two specific teams, right? This was Team Red Hat. They do Linux all day, every day. It was also Team Talos. If you're not familiar with Talos, they build Sidero and Talos Linux. These are custom Linux operating systems for running Kubernetes. So we had these two powerhouses of Linux contributors that know Linux inside and out, and it just was complete serendipity that it came out this way. So the easiest way to fix this is Perl has the ability to execute most syscalls on a machine, and you could have done a Perl-E, but they removed Perl. So what we learned from this episode is you can actually execute the dynamic linker on Linux. So we have this ld-linux.so, and you can actually execute any binary on a machine by proxying it through that linker. So you can chmod, like so, which is a really cool trick. Also on clustered, we've seen people modify attributes on a Linux file system. Anyone know what attributes are in a Linux file system? No, of course not. Why should you? So, attributes allow you to actually get really low level into the file system. And here, we're actually marking a file as immutable. And you can do that with change attra command. So you can pick a file that you know kubecontrol or Kubernetes has to write to, mark it as immutable, and you've immediately broken a system. And you're not going to be able to detect that break by running your regular ls command. You actually need to do an ls attribute on the file and then understand what these obscure references mean when you list them all. So again, clustered, it just gives us this environment where we get to extract all of this knowledge from people that have done stuff that we haven't done before. And again, that's just fucking awesome. So there was another very, very serendipitous episode with Chris Nova and Thomas Stromberg. Chris Nova is a kernel hacker that's worked in security and Kubernetes for many, many years. Thomas Stromberg was the maintainer of Minikube at Google. Also very smart, been doing this for at least 20 years, and coincidentally used to work in forensic analysis of intrusions at Google. I didn't know that, but when he came onto his episode and Chris Nova hacked Kubernetes, didn't break it, literally rootkitted the Kubernetes, Thomas came on and ran this FLS command. Who knows what FLS is? Of course not. It's this very old toolkit written in the late 90s called SleuthKit that does forensic analysis of a file system, a Linux file system. And by running this command, he got a time-ordered change of every modification to the Linux file system. He had every answer to every question he wanted to answer for the last 48 hours that Chris Nova had that cluster. And again, anyone else was up against Chris Nova in that episode, they were not fixing it. So I love that we have these opportunities of complete serendipity to share knowledge with everyone. So Linux is a pretty good attack surface because it's a very complicated operating system if you want to get into the low-level specifics. Want to know what else is hard? Networking. And we've had a fair number of networking breaks on clustered too. What people don't realize with Kubernetes is that we have core networking policies. However, we're now seeing fragmentation as other CNI providers bring on their own adaptations to network policies. So it's not enough to check for network policies or cluster network policies, but we have Cilium network policies, Cilium cluster-wide network policies, and even Cilium local redirect policies. So not the attack surface specifically, but the understanding surface, the things you need to know to successfully operate a Kubernetes cluster from a networking level, continues to evolve and get very cumbersome, scary, complicated, but also easier. My biggest frustration with Kubernetes is the default DNS policy. Who thinks the default DNS policy in Kubernetes is the default DNS policy? It's not. We have this DNS policy called default, but it's not the default. The default is cluster first, which means it's going to try and resolve the DNS name within the cluster And the default policy actually resorts to the default routing on the host. So, passes the eyeball test. You've got this configuration. You could be looking in your kubelet conf. Yeah, this looks great. It's perfect. No, it's not. And I hope, and I've been discussing with people like Tim Hawken and other core maintainers of Kubernetes, how do we remove some of these anomalies that are they're essentially foot guns for people that just haven't encountered these problems before? Moving outside of Kubernetes, when it comes to Kubernetes networking, we have the host. We have EB tables and NF tables. We have quality of service with something called traffic control. Who's heard of traffic control? Okay, couple of hands, good. There's lots of ways to change how networking happens on a host. And more recently, we have Extreme Data Path and eBPF, which is changing the landscape completely as well. It's not, you can't just go into a Linux machine anymore and run iptables-l, which I'm sure we all have ingrained in our skulls from the last 20 years. But now, who knows how to list all the eBPF probes or traffic policies in a cluster? Essentially, you can. You need to have other eBPF tools that can understand the existing eBPF tools. Unfortunately, Cilium are leading the way here. So a good tip is to check out Hubble. Cilium provide Hubble, so you have to be using Cilium CNI, of course, but you get this wonderful visual representation of all the networking policies, Kubernetes specific and Cilium specific, and it shows you with nice little arrows and pointers what services can communicate with each other. Very valuable tool. So Hubble also ships with a CLI. So we did a special cluster where I tried to actually confuse the Cilium team. The Isovalent team joined me, and I thought, I'm going to use your own tool against you. And I used a local redirect policy. This allows you to do host-based DNS resolution by saying, every time I want to speak to this service, don't let them speak to that service. Instead, make them speak to this service over here. So as you can see here, they're doing a Hubble observe and grepping for port 5432. Postgres. However, I misused the local redirect policy and sent them to FluentD. So they weren't actually able to communicate with the database at all. However, Duffy is a very smart man, and he ran the Hubble CLI and actually seen, hey, Hubble's showing me that we're speaking to FluentD instead of Postgres, what's going on there? And within 30 seconds, he removed my local redirect policy. So we have the tools to understand networking within our cluster. If you're lucky enough to be in Cilium. If you're using other CNI, you will have to find other tools, but they do exist as well. My favorite thing about Cilium is the editor. So you can actually go to editor.cilium.io and you can build a Kubernetes networking policy or a Cilium network policy by dragging boxes, changing labels, and changing port numbers. So you don't actually need to learn how to navigate these esoteric YAML files anymore. Use the tooling that's provided. What's also really good about this is you can take an existing network policy that you have in your cluster, drop it in, and it gives you that visual representation too. So whether you're debugging existing policies or writing new policies, everything in the Cilium editor is there and available to help you. All right, next I'm going to talk about etcd. I'm not going to ask who's operated etcd, instead I'll ask who enjoys operating etcd? Not a single hand, of course not. This is the one thing, when we do the pre-prep on clustered, I generally ask people what they don't want to see from the other team. And every single time it's, please don't touch etcd. Or certificates. Certificates are also up there, but I think etcd probably just tweaks it. Most people swear, so when they go, oh, it's an etcd break, they don't normally say it as politely as that. Like that moment it sinks in, there's dread and fear. Because you can't just bust out the etcd CTL command line. You have to prepare it with a whole bunch of environment variables to tell it to speak v3 etcd, and then point it to all the right certificates, and then eventually you might be able to run etcd control health or status. So, not easy to start debugging when etcd is the problem. What we've seen is that etcd comes with a default database maximum size of 25 meg, and it can be configured. So what people like to do is saturate that. They write a whole bunch of crappy data into etcd, it hits the max file size, and you'll be presented with an alarm which says no space. Now, you may think I can resize the database, restart etcd, and things will work. No, of course not. SCD will not manually clear that alarm when you've rectified the problem. You actually have to explicitly and intentionally disable the alarm, and then SCD will begin to work again. So SCD, I wish it was easier. There's lots of things that are easy to break, and you have to have all of this knowledge. Again, you have to have failed a whole bunch of times just to cover the basics of operating SCD in your cluster. Which is why we all find managed Kubernetes offerings so appealing, right? Probably. One particularly cruel episode, a team turned on encryption on my Kubernetes cluster and didn't re-encrypt or didn't encrypt any of the data in etcd already. And then we were running kube control commands. We weren't able to get anything back. And honestly, this one stumped me. Like I've actually never, until this episode, turned on encryption on my etcd cluster. And so what's a really cool thing to do is actually, they watched me suffer for 20 minutes as I was writing a bash script to pull out keys, encrypt them, and write them back in. But you can actually enable dual mode. And the config for there is in a second, although you don't really need to read it. But you can turn on this blank identity. And it means that etcd will support reading unencrypted keys and encrypted keys. And then all you need to do is actually just get all secrets, all namespaces as JSON, and then replace them straight back in, and you've encrypted your cluster. But unless you've had to do this, you don't know that you need to do this. And this is the config. You just enable identity on the bottom. All right, so where to next? There's a lot of ways to break a Kubernetes cluster. This word cloud is probably not that comprehensive, and I wish I had more data from all of the episodes. But you know, you can attack the container runtime. We've had people recompile the kubelet and remove certain controllers so it can't spin up pods or containers. We've had people roll back the kube control binary 25 versions. So it was running kube control 0.8 or some silly number like this on a cluster that was running 123. Why did they roll it back 25 versions? Because rolling it back 24 versions didn't actually break it, which is pretty cool. And they kept rolling it back one version until it eventually broke and didn't speak the same API language. So we have this nice thing, and that the Kubernetes maintainers are really good at ensuring we have a level of backwards compatibility, but there's still, you can push it too far, and they definitely did. We haven't really discussed storage, but if you're operating bare metal Kubernetes, you've got to worry about your own CSI providers, and that is another very challenging aspect. There's also backups, there's auto-scaling, there's horizontal pod auto-scaling, vertical pod auto-scaling. There's a whole bunch of ways to break a cluster. And then there's the security aspect of this, right? What about seccomp? Are we doing that in our clusters? Are we minimizing permissions? Lots and lots of ways. And I would say if you want to learn more about these things, if you find this interesting, go to the YouTube channel. There's over 50 episodes, and absolutely go nuts. However, what I really want to cement here is that you're not supposed to know this stuff. Right? You only learn this stuff when things go wrong. So if you've been exceptionally lucky and these things haven't gone wrong, then a lot of these breaks and a lot of these principles may seem really foreign, but that is okay. And one of the things I always tell our guests at the start of every episode is that we want to normalize saying, I don't know. The one rule I give people is please don't sit there quiet, Googling off camera to get an answer and go, oh, I know how to fix this. Because that doesn't benefit the audience. I actually want to normalize this, that I've been doing this, I've been doing Kubernetes for 6 years. I've operated bare metal clusters, managed cloud clusters. I think I've seen an awful lot, and clusters has made me see even more. And I still get stumped every single episode because there's so many different attack surfaces to break a Kubernetes cluster. So just make sure you're bringing this into your team. If you are an SRE or platform engineer, you're helping operate Kubernetes, say I don't know more, especially if you're principal or senior. Let's normalize this for other people on the team and try and dismantle this terrible hero culture that we've adopted over the last 20 years. So we all find this difficult, and I encourage you all to learn in public too. I do this on my YouTube channel because it's actually kind of selfish. I get to learn more from other people, but at the same time, I'm hopefully producing content that we can all learn together. And what I want to see, or I'd love to see, is more people sharing their Kubernetes knowledge out there. And we have some really good resources as well. There's Kate's AF, I think it is, which is all the horror stories from other people that have operated Kubernetes. But we really should share as much of this as possible. So to kind of finish up my talk, I want to share what I'm learning now and what I find really interesting. And that is eBPF. I genuinely believe that eBPF is going to change everything with regards to the way that we operate not just Kubernetes, but container-based workflows and Linux. And the reason it changes everything is because it's super performant. It runs, am I over time? No. It runs in kernel space and not user space. It uses ring buffers and other fancy stuff, so that you don't take any sort of hit when you start at deploying eBPF probes to your clusters. It also does some really cool tracing. We now are very lucky to have continuous profiling tools that don't need to understand the runtime. They don't need to speak the Go kube-proxy protocol. They don't need to understand PHP as a runtime. They don't need to understand the JVM. We're able to instrument all of our applications at the eBPF level, which is very, very cool. And also, it's safe and secure. Because eBPF programs have a limited subset of calls they can make, it should technically never crash or cause you any problems in your kernel. Always edge cases. And the tools that I want to highlight that I think if you're interested in eBPF and you should be looking at is 100% Cilium from Isovalent. Hubble is built on eBPF. It's an eBPF powered CNI. You actually don't need the kube-proxy, which I think is also very, very cool. Falco from Sysdig gives us security monitoring of our workloads, actually detecting at the syscall level if our applications are doing things that we don't actually expect them to do. And it requires zero instrumentation on your part. Inspector Gadget from Convoke actually exposes all of these Snoop tools that I'm going to demo one or two of in your Kubernetes cluster as well. And Pixie by Pixie Labs, which is now owned by New Relic, but they've kept it open source and free, gives you automated instrumentation monitoring data for any application, again, based on eBPF. So you don't need to go out and jump to OpenTelemetry and add loads of lines of code to your application to start monitoring. You don't need to add your own Prometheus metrics endpoint. Well, you should. You can deploy Pixie and start to get a lot of this information for free at a small performance overhead of an extra container in your workload, right? The most interesting stuff for me, though, are these Snoop tools. Exec Snoop you can run on a machine, and it will tell you anytime anybody or any process executes a command on this machine. IO Snoop will tell, and Open Snoop will tell you when files are opened, written to, closed, etc. on the machine, and then we have a whole bunch of stuff for networking too. And in fact, if I find my terminal, which is here, and SSH onto a Civo box that I spun up this morning, we can actually run a couple of commands. So on the top, I'm going to, I'll fix that in a second. I'm going to run exec snoop. And I won't reject my 1Password prompt this time. Okay, so we can already see a whole bunch of things are happening just by me logging into the system. Now, I could run echo hello, but it's not going to show up. Does anyone know why? It's a built-in to bash. It doesn't actually execute anything on the machine. However, we could run bin echo, and we see it on the top pane. What's really cool is when you start filtering that data for things that you don't expect to happen on your box. Here, we can actually see that sudo is called, we see the parameters to sudo, and we understand when privilege elevation happens on our machine. So exec snoop is just an example application of hooking an eBPF probe into your system to get information out. The last one I'll show is open snoop, which will actually show you every time a file is read or written to, etc. And you can even see as I type, things are happening because of the way file descriptors and the fact that everything on Linux is a file. But now we can see that someone read our etc password file. Now that's actually not that scary, it's all hash passwords and stuff like that. But you may have sensitive parts of your system that you want to monitor for file descriptor access that you don't typically expect. So eBPF gives us visibility into disk, into network, into processes, all those important parts of the kernel where security considerations become extremely important. So I generally believe that eBPF changes everything. I already did it in a quick demo. And now I want to talk quickly about the risk element. So if we want to understand what the risks with Kubernetes are and why eBPF is really important, container breakouts are extremely low, not low, high risk, but unlikely, right? We don't see container breakouts every single day. But eBPF can tell us when we have a break, not specifically. We can tell when a user or a high UID does something on the host that we don't expect it to do, which may be an indication of a container breakout. We can start to profile these different things that we don't expect. Lateral movement in a cluster, pods executing commands that we don't expect. Like if you see an apt update in a container, probably a big red flag. If you see an apt install of DNS query tools, it's probably people looking for that lateral movement. If you see curl to domains that you don't expect, again, all the information is there. Now, of course, you're going to have network policies, and you can't curl domains that they're not supposed to, and attackers shouldn't be able to have access to a right file system. It would be read-only. I'm sure you're doing all that best practice, right? Just nod. It's all right. So we have to detect that lateral movement, and eBPF gives us the keys. It gives us everything that we need. And then, of course, what's more likely and higher risk in our Kubernetes cluster is that something on the host is going to expedite access to people that we don't want to do. And again, eBPF gives us access to all the things happening on the host. We can profile our attack surface, and we can monitor it. If you want to learn more about eBPF, the canonical resource is probably Brendan Gregg's book, where he talks about performance tools. He's really driving a lot of what's happening in eBPF and works at Netflix. The Snoop tools that I just showed you are all part of the BCC IO Visor group. Again, they're providing a lot of the helper functions, where that C programs or Python programs that do interpretation of eBPF programs. All the code is there. Like, you don't need to go and learn how to write an eBPF program. You can grab the code for exec Snoop, which is not that big, and then tweak it. Do the filtering, monitor for what you need, or just use file code. Up to you. The scary example is the last one. So the team at Datadog did a talk at a conference a couple of years ago now, and they built an undetectable rootkit in eBPF. It's very difficult to find what existing probes are in your kernel, so they can actually hide their rootkit as eBPF probes, and you have no idea that it's there. So, go check out that link, but don't deploy it to anyone's cluster that you don't trust or they don't trust you. That would not be very nice. So, I would encourage you all to find what is interesting for you, learn in public, and share that knowledge with everyone else so that we can all learn together. Thank you so much for your time. I hope you enjoyed this talk. Please check out Clustered, and I'll see you all soon.